Well, hello everyone. I guess we'll wait a couple of minutes and see, give some other people a chance to log on. Hopefully everyone's having an enjoyable evening. Should be a lot of fun. And thanks for coming aboard. Well, all right. Well, hello everyone. Welcome to this Facebook Live. I'm Butch Bolzano, and today we're covering how to use a digital multimeter for beginners, especially for us RVers. A quick intro of who I am, and you know my background, so you'll know my background. I've been an electronics professional since 1974. Graduated from the Rhode Island School of Electronics in that year. From 78 to 99, I owned and operated Rhode Island Musical Instrument Retail and Warranty Repair Center. And since 99, I've run my own successful independent electronic repair shop, still providing factory-authorized warranty service for JBL and designing custom electronics for some of the biggest artists in the world. Recently, I've gone deep into RV subsystems. I earned my RVTI Level 1 certification, currently studying for RVTI Level 2, completed multiple hands-on Victron Energy training camps, and hold certificates from Firefly, Lippert, and Dometic in RV subsystems. So, without further ado, tonight I'm sharing simple multimeter skills that I've used for decades to troubleshoot electrical issues. Skills that can save every RVer time and money. So let's get started. It's going to take me a second to switch screens, and we'll move on. So first things to get out of the way, we need to understand some safety issues first. First thing is, electricity doesn't play nice. Always dry hands, never have wet hands when you're playing with anything electricity. Never in bare feet. In other words, don't be standing outside the RV in your bare feet with your meter in your hand testing 120 volts. Never touch live wires with bare hands. And be extra careful with 120 volts AC. That certainly can hurt or kill you. If possible, you should turn off the power when checking fuses or breakers. But I'm going to show you a couple methods where we can check those without turning off the power. And of course, if you're unsure, just by all means, please call a professional. So let's get into it. So the next photo that's coming up is a bunch of meters that I personally own that are in my, shall we say, arsenal of meters. The one that my ugly mug is covering is a meter that I use just about every day in my shop. The one to the right in the middle with the turquoise cover is a manual ranging meter, which we're going to go over in a minute. The meter to the left of that is a meter that is a data logging, that I can log data instrument into my computer if I want. The top meter, orange on the right, is a Bluetooth meter, so that sends readings to my phone if I needed to have something done remotely. The next little orange meter is a meter that we're going to be using tonight. And the one that looks like the orange loop is a current meter, and that's currently the meter that I carry in my Vita. So, moving on, let's get into looking at some meters. Wait for that. You're going to understand I'm working with a 5 to 7 second latency transition from photo to photo. So this is now live. Here's my hand. Here's 2 meters. The one on the right is a manual ranging meter. You can see that it's got a bunch of things around it. And the one here is an auto ranging. It's got far less positions for its dial. And we're going to go over all of those and show you which ones what they do and which ones we need and which ones we don't. So let's go with this one first. So this meter is a manual setting meter. Let's zoom in a little bit. First things first. So these are all different ranges and different types of things that you're going to use your meter for. This down here, let's start from the 7 o'clock position, and we're going to work our way around clockwise. So this is amperes, and the squiggly line is actually what's called a sine wave. So this would be AC amperes. So if we were going to measure AC amps, we would select the meter in this brown range here, from 10 amps, 200 milliamps, 20 amps. Not anything we're going to use. The next one up is NCV, which stands for non-contact voltage. It's something we're going to cover a little bit as we move on, but it's a handy feature for a meter to have. The next function is looks like an arrow pointed to a line. That's a diode, and then this speaker symbol, and this is for continuity. This is something where we're going to use to measure fuses to see if they're open or they're shorted, or a piece of wire, what have you. So this is a function that one of the few on this meter that we would use. The next section is ohms. You see the omega symbol. This is a value for resistance, from 200 ohms all the way up to 20 megohm. We rarely use that for testing purposes for what we're going to deal with in the Vita Portos. This function is for testing transistors, not to know about it. Now we're getting into the meat of what we're going to do with a meter. This is voltage DC, so the lines are straight with dots underneath. So that signifies that this is the DC range for this meter. And it runs from 200 millivolts all the way up to 1,000 volts DC. The next section is volts again, but it's got the squiggly line, which again, as we mentioned back here in ampere, is for a sine wave. So this is AC volts. And in this case, this meter will read from 2 volts up to 750 volts AC. And lastly, we have amperes, again, like this one, but this is for DC. So this measures DC amperes. So a bunch of functions that this meter does, but really we're only going to be concerned with just these few. We're going to be concerned with, if you have a meter that has this layout, voltage DC at 20 and voltage AC at 200, and the little continuity section here. So those are really all the ones you're going to use. You would rarely ever use amps. This meter is not an amp clamp, so it only is an upper range of 10 amps. have far more DC and AC amps going through our vehicles than what this meter can handle. So again, if this is the type of meter you have, really the only functions you need to know is this one, voltage 20 volts, voltage AC 200 volts, and continuity. So let's move to an auto ranging meter. So here's another digital voltmeter. Excuse me, I get a drink. So this DVM is auto ranging. So in other words, here's our DC volts, the volts with the lines again, but there's only one because it auto ranges. It automatically sets the display to the best range so you can get the most accurate display of voltage in this case. And again, AC volts. There's the sine wave signifying that this is our AC volt, but there's only one. This is again the diode, the ohms, and the continuity. All three, and we're going to go over how to select those in a second. This is a symbol for a capacitor. If you have a start capacitor in your AC and you want to test it, this meter can do it because it has an a capacitance check, but something you're not going to use. Hertz. So this meter will measure frequencies, and it's measured in hertz. Again, we're not going to use that. And then now we have different amperes. We have microamp, milliamp, and amp. So UA, MA, and A. So these are, again, the current readings like we had in the other meter, but this time they're auto-ranging, but we're not going to use current for that. And then finally we have NCV, which is the non-contact voltage. So if you're new to meters, we'll take this meter for instance. It has three little sockets in the front for probes. The red probe always goes in the voltage and rarely ever moves. Common or ground or black goes in the COM, and that one never moves. That always stays there. If you were measuring current, just so you know, you would put this lead from here to here, and then you could measure current, but it's not something we're going to do. So now that we know that by the way, these meters have a really neat kind of function on the back. So a lot of people ignore this little thing here. So this section is like a third hand, and you'll see me in the photos we bring up, you'll see me use this quite a bit because I need to hold the meter, the other lead, and my phone to take the pictures that you're about to see. So you can snap the probe into the back of the meter and then hold it on the ground or a hot at different lengths. You can put it anywhere you want on the meter, really. But it's kind of a neat function, so I certainly wanted to show you that on the back. All right, so let's get started and start measuring some voltages and show you what this little guy can do. So what I have here is a LiPo battery, just like the ones we're putting in our RVs, except it's a tiny one. It's only 8 amp hours, and I'm holding it in my hand. But it's fine for me for testing because I can look at the voltages when I'm charging, discharging, or checking an MPPT on the bench, and actually not have to have a giant 300 or 100 amp hour battery to do testing. So let's turn the meter on to DC volts. So a couple things to point out in the display. The meter tells us, I think we can see that. Yeah. It's on DC volts. It's flashing because it's auto ranging. It's looking for some voltage and we have nothing coming in. I'm still holding the probes in my hand. And it's looking for something for an input. It says auto right here. And this little circle means that it has an auto shut off, so it's like on a timer. But that's what these things tell us. On this side of the display, it says millivolts, which is what it'll default to when the meter doesn't have anything coming in its input. Obviously, I'm holding the leads and not connected to anything. So it's going to read the smallest voltage available, which is a millivolt. So now we're going to take our meter and we're going to take our battery. Let me zoom out a little. Maybe I'll move my mug up here. And let's move that so you can see it better. Transition. Okay, so we're going to take our meter probes, black and red, and we're going to insert it into the meter. I mean into the battery post. So black on the negative and red on the positive. And look what the meter says. So the meter is telling us that this battery is 13.59 volts. It doesn't say millivolts because now we're up into the voltage range where it auto-ranged and said, I can't find a millivolt, so I'm going to give you the voltage reading of 13.59. Now, here is something very, very important that you need to know when you're measuring DC voltage. This meter will tell us which direction we have our probes in. So right now, you can see I have the red probe on the plus and the black probe on the negative. And watch what happens to the meter when I switch it. Did you guys notice? So if you notice, you'll see there's a line right here, and it's telling us that it's negative. In other words, the probes on this particular battery are set where it's going to read a negative voltage. Again, I'll put it back so you can see it. But this is now telling me that the probe's reading this battery as a negative 13.6 volts. Let's put it back. You'll see that that negative disappears. You see it's no longer there. And 13.59 volts. Now the reason that you want to know that and be cognizant of that negative symbol is we're going to go and test the output of the ZAMP, solar input on the side of the Vita. And to get the connection correct so you don't blow the fuse inside, you want to make sure you know which one of those pins is positive and negative. And the meter is going to tell you that. Got that? All right. So the next thing we want to look at is AC volts, which we're going to measure in a couple things in a little bit. But really what I wanted to get to next is the continuity part of the meter. Excuse me. So in this meter, it has this function button. Right now the meter is set to ohms. As soon as I clicked it to that function, it automatically gives me the ohms. You can see the, let's get the battery out of the way. We'll zoom in a little bit for you. You can see the ohm symbol here. So right now, even though this does 3 different functions, right now it is set to ohms. To change it, all I do is hit the function button. If I hit the function button, now I have the diode symbol there. And then if I hit it again, I get the little speaker symbol. And this is what we want to know, or what we're going to see. So if we touch the leads, right now it says over limit or overload. It's actually over limit. Because we're on continuity, since the leads aren't touching each other, it's going to show an OL. And listen and watch what happens when I touch the leads together. So the meter beeps, and it goes to all zeros, which shows it's a short. Open, overload. Close them together, and it's a short, and you hear the beep. So that is a really helpful way of checking things like fuses, circuit breakers, and pieces of wire for the most part. If you want to check continuity, make sure one end is actually connected to the other. And that's what continuity does. You can also obviously do the same function with a resistance by going to your ohm setting. And instead of beeping, it's going to measure the resistance between the two probes. And right now, because they're touching, there's no resistance between them. And now they're open. So that's the most handy features of this meter. So really, it's these three functions. As a new person just getting into running a DVM or a meter in your RV, these are the functions that you really need to master. And it's really the only three you need. The rest of them you're not going to use. And again, we'll cover NCV in a little bit. Okay. So we're going to go transition to some pictures of, as soon as I can find them, get the detail camera off. So the next thing that's coming up is a picture of this meter, but it's actually measuring the battery voltage in my Vita. It's taking its sweet time to transition. Here we go. So you can see I've got it on, it's on DC volts, and I'm reading between the positive of my battery switch and the negative lead. You can't really see it that well in this photo, but it's on the negative side of the smart shunt. So you can see I'm reading 13.52 volts DC. So this is a good way to check your, obviously check your coach battery. You take the step off, that's where the batteries live, underneath that step. And then you'll find your batteries, whether you have lithium or AGM or sealed lead acid or flooded. And you can measure directly right on the battery with the meter in DC volts. By the way, I should bring this up too. There's some meters that have a BAT selection. In other words, you can measure voltage, battery voltage, and sometimes they'll say 1.5, 9, and 12. Do not use those functions. Those have a small load in them to test the function of a battery, a dry cell, and don't use the battery setting if your meter has that in these functions. That's not something you want to use. So this is just showing you that you can check your coach batteries right under the step with a digital voltmeter. And you just put one probe on the hot and one probe on the negative, and you should be able to read the voltage. Now, we're going to cover this in a little bit, but the voltage there is going to vary depending on a couple of functions. One, if it's daylight and you have a lot of solar, and charge controller, either if you have a ZAMP or you've upgraded to an MPPT, the voltage at the battery is going to be higher than the actual battery resting voltage. And the reason is that you're going to be measuring the voltage at the battery, but it's also getting input or current being fed to it, voltage fed to it from an MPPT. Also, you could be measuring the voltage and your converter is on. You're plugged into shore power, your generator's running. That will also raise the voltage of your coach battery and kind of give you not a false reading, but it's not a true reading. You really need to wait until the batteries settle without any input. In other words, the best time to do it if you no solar, if you can't shut your solar off, which if you have a current Vita Porto and you haven't made any modifications to it, there's no real way to shut the solar off during the day. But at night, there's no solar, so the batteries will give you more of a truer voltage at that point at night than they will during the day of what the actual battery is. So there's a place where I'm using the meter to check the coach battery. The next pick is you can use the meter to check your chassis battery. Here is the same meter. I have a little, you see the green on the right, it says meter ground. So on our sprinters, there's a little stud sticking off of that side of the fender, which is where you're technically supposed to add or put your negative jumper cable or what have you. That is what is the recommended ground. And that red device that you see the meter pointing is sticking in is a spring-loaded device that has the stud for the positive of the chassis battery. And by the way, you can see that I'm using the probe stuck in the back of the meter. You can see that there while I'm holding my cell phone to take this photo. So I just pushed the red object is a cover because that is a live wire there, or a stud. So Mercedes had spring loaded, so you have to turn it and then push it in, and you have to hold it in because it'll push itself back out. But I was able to jam the probe into that to give me the battery reading. So you can see that my chassis battery is at 12.72 volts. So again, here's the DVM, or a little digital voltmeter. Not only are we checking the coach battery, but now we're also checking the chassis battery. So, this is a section of the RV. What you're going to see pop up is the cover over on the driver's side, driver's seat pedestal, and it has a bunch of fuses behind it. These fuses, which I'm not going to get into because there's a supplement in the manual that tells you what they're for. But these fuses are for various functions in the Mercedes chassis. A lot of them will be used for the house, basically. I know that there's a couple of fuses here that are used. Here's a picture of it with the cover off, that are used for the PSM and possibly the lighting. Here's a quick tip. You see that there's a lot of empty slots in there. Do not indiscriminately just pull fuses out because they're going to be hard to remember where they go back in. So my suggestion is if you do need to remove one, is to take a picture with your phone and do it, in other words, straight on. Don't be standing up looking down at it because you get what we call parallax, and the picture won't give you a true indication of where the actual fuse is. So you can see in this picture, I'm just about, my camera phone is just about in the same parallel or axis as the fuses. So something you can check. Unfortunately, this would be a good place to check the chassis battery by measuring between one of the fuses and ground, except that all of these are dead when the RV is off. When the chassis is off, none of those fuses are live. So at the end of this, we'll get into a suggestion from me of what is a good recommendation of how you can get your chassis battery and coach battery monitored pretty efficiently without using your little meter. But if you don't want to go that route, or you don't have a need to, then you can use the method that we just showed you. So the other thing is there's only a couple of fuses in the driver's seat pedestal, but there are quite a few in another place that you may not know about. And they're under the passenger footwell. So passengers' feet rest on this device, or it's actually just a cover. You can take a quarter and turn those two, look like big giant straight screws, but they're actually plastic fasteners. And under those, if you haven't been there yet, is kind of a mini Sprinter toolbox. Hang on. Yeah, taking its sweet time to change over. So there's a lug wrench. There's here it is. There's a lug wrench. There's the tow eye. In other words, in your front bumper, if you look on the passenger side, there's like a little door, and if you open it, it's a threaded piece that item on the left screws into, that you can actually pull the Mercedes chassis. But that is hiding this. And as soon as it shows up here, there is a plethora of fuses of different shapes, sizes, fuses, circuit breakers, relays, a whole bunch of things. There you go. Different size fuses, relays, all kinds of things that are underneath the passenger's feet. And you can see a large harness of wire that's feeding those. Again, that is all spelled out or in the supplement that comes with your manual. If you don't have it, by the way, or if you bought your Vita Porto used, you can go to mbvans.com, go under owners, and then you can click on owner's manual, and you can get the manual for, well, I guess it would be 2018 all the way up to 2024 for Vita Portos. The other section that we can look at, and we're going to go over, have some fun with circuit breakers in a second, is under the passenger seat. You guys have seen this cover, and it says automotive coach circuit breakers, battery modes, solenoid, and relays. That cover covers this. So it's funny how they say solenoid and relays, because you can't really get to those by taking that cover off. But here is this is a previous version of what my move my mug over there. Transition. I had added, for the most part, the white round circuit breakers with the numbers in between them, the 30, 15, so on and so forth, 40. I added the two switches on either end because I installed a Victron Orion DC to DC converter, and I also put a switch on the ChargeMate that I can toggle its function on and off as needed. So those are circuit breakers, not fuses, and I'm going to show you what those look like, what they do. We're going to take one apart, and it'll be kind of fun. So the next section of the Vita Porto is the WIFCO distribution panel. So this on a P series is under the bed, And I believe on an F it's in the same place. Excuse me. So this has got several items hidden inside it. First off, this is what mine looks like. I highly suggest that you label it like this. The reason being is, in the middle of the night, if something blows or something, the writing that whoever at Winnebago wrote is really hard to decipher. So I took a P-Touch and I made all new P-Touch labels for all of the functions in here. What you want to note is on the right hand side, I'm going to move my mug, you'll see that I labeled all of the fuses. It says lights, 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 USB 12 volt, monitor panel, so on and so forth. Yours does not have Starlink and those are for my underglow LEDs. But note one thing, if you're going to do this, take it one extra step, and you'll notice that next to the lights, we'll pick the top one, it says -JC. That is the circuit on the Winnebago schematic that tied to that fuse. In other words, if I had to look at the schematic, if that fuse blew, I know right away to go to the schematic and look at JC, because that's the wiring for that fuse. So I looked at every one of the fuses and wrote next to them what their schematic designation is. So in this case, go JC, JD, JF, all the way down, except for Starlink and LEDs, because those are fuses that I added. So the next photo is what the WIFCO panel looks like inside with the cover off. It has three basic main parts. We have the AC circuit breakers. We have the DC circuit breakers, or DC fuses, I should say, sorry. And on the bottom is the converter. That is the AC to DC converter. That when you're plugged into shore power or the generator is running, you sometimes will hear a fan running in that WIFCO panel, and that's the fan for the converter. So this object on the bottom with the silver, those are heat sinks, aluminum heat sink. Those silver heat sinks are part of the converter, and what its job is to convert AC coming in from either shore power or the generator to DC to charge the coach battery. And so that whole section, WIFCO converter, it can be broken down into three major parts. Obviously, AC circuit breakers on the left, DC fuses on the right, and AC to DC converter on the bottom. Here is a close-up of the DC section. Get it to load. And what we're seeing here is I want to point out a couple of things on the DC section of the converter. And what it is those big Phillips head screws you see to the right of the fuses. The top one, labeled in green, is our coach battery and converter ground. In other words, the coach battery, the battery under the steps, the ground from that makes its way all the way back to that lug, to either one of those two Phillips head screws. There's very large wire underneath those, and they're tightened down. By the way, generally the yellow marking is that someone had tightened that to a certain torque spec, and then they mark it as such. So that's why some of those have yellow paint on them and some don't. The single below that with a red wire you can see peeking out to the left is the converter's positive output. So that AC to DC converter underneath those fuses, its output connects to that lug right there. The two 40 amp orange fuses underneath that are reverse polarity fuses. So their job is that if you hooked up your coach battery incorrectly, in other words, you wired the positive to the negative to the positive, it would blow those fuses to protect the converter from damage. So those two big 40 amp fuses, their only job is the reverse polarity for the converter. Again, the positive of the AC to DC converters, that lug that I have circled in red above it. And finally, below, there's two more lugs. That is our chassis and converter positive. Up on top in green, we have the coach and battery converter negative, and at the bottom we have the positive. So the big wire from the battery actually comes from the solenoid, goes all the way back to that lug. So those are something to note, and the reason is you're going to see what I did to test at the panel with just an 1/8 inch hole in the plastic. For now, ignore that blue upward arrow because we're going to show that in a second. All right. The next photo should be, where are you? Don't lock up on me now. Is the converter batteries. I can measure the converter battery by putting my meter on a fuse and then toggling the converter circuit breaker, and I'll show you that in a second. Converter labeled, yep. So you remember when at the few slides back, I showed you what the voltage was at the battery. I had the meter under the step and was actually measuring the battery. Here's where I am measuring the battery again, right at the panel with the cover on. So what if you'll notice, before the battery voltage that I had under the step was 13.5. and here it's 13.43. You'll look closely, you'll see that the red probe is touching a fuse and the black probe just goes into the plastic. So what I did is I drilled an 1/8 inch hole right on top of one of those two ground screws that we discussed just a bit ago. Because there's no way you can find a ground without taking the cover off, the WIFCO cover, it's super easy just to put your probe on one of those two Phillips head screws at the top and use that as ground, and then use your red probe to probe any of the fuses because they'll all have the battery voltage on them. So you can see here that I am measuring the battery voltage at the panel. It's not exactly the same. There will be a voltage drop of sometimes up to 1/10 of a volt between what you see at the battery and what you see at the WIFCO panel. And the reason being is that there's a lot of wire, it's heavy, it has resistance, and over that span it will lose just ever so slightly, and we call that voltage drop. Here is a picture, next coming up, of the hole. So all I did is I just took kind of measured where those two Phillips head screws were that have the ground, and I drilled an 1/8 inch hole in the plastic so I can stick my probe in there, and now I can at least measure DC voltage at the panel with just a simple 1/8 inch hole and just using my little meter. The next function on the WIFCO panel, thing I want to show you on the WIFCO panel, I should say, is WIFCO gives us a fuse out or fuse blown indicator. So in this photo that's up currently, excuse me, you see a blue arrow pointing to a red fuse. That is my under LED system fuse. What I want to point out is you see all the yellow wires to the right, and there's 2 red wires underneath. Between those wires and the fuses look like just little black specks. Those specks are actually a resistor, a transistor, and an LED for each one of those fuses, and it's a fuse out indicator. In other words, if one of those fuses in that row should open, an LED will come on. So note the red fuse, because the next picture, the red fuse I pulled out, and then look and see what happens. Because WIFCO gives us this ability to actually check a fuse instantly with an indication that a fuse is gone. In this case, I took the fuse out. It would still be analogous to having an open fuse. It's just not there. But you see the green arrow is now pointing to an LED. And the LED is telling us that the circuit is still live. In other words, the red is still connected. It just has no voltage going to it because it's powering the LED. So kind of a neat thing that they gave us. So now let's transition, since I probably bored you to tears with that part, back to our live and get our meter back up. And we're going to test some fuses and voltages, continuity and such. So let's get that going here. All right, we're back live. Yep. So here, I'm going to grab a couple of fuses. These are ATC fuses. This is a good fuse. If you look here, you see that little S, that squiggly line, which is connecting these 2 points of the fuse together. So that is a good fuse. This is a bad fuse. If you look, you see that there's no connection here any longer. So this is a blown fuse. We're going to measure 2 different ways fuses so you can get a good idea how to use your little meter to test fuses. And I'm going to show you one that's kind of unconventional, but I think it works very, very well. We're not going to use continuity. We're going to use voltage to check the fuse. By the way, in the under the passenger pedestal are fuses like this. Basically do the same function, just much, much smaller. And you can see the fusible element right there. So let's turn our meter on. We're going to go to continuity. Remember that is the speakers. We're going to hit function twice. We're going to make sure always when you check continuity, you always want to touch your probes make sure that it is functional so you know you're getting what you're expecting. Take a fuse, doesn't matter good or bad because we're going to measure it. So you put the probes on the fuse and this fuse is open. The other cool thing that I want to show you on these fuses is that we can do what's called back probing. You see the two silver spots? Those are a continuation of the fuse to the top, which enables you to check the fuse while it's in circuit. So we can put the probes on there, and of course we know this is still open. Take a known good fuse and we see we get continuity, and same in the back. Come on, I've got to look up, and here we go. So we can use the meter to check a fuse two ways, either directly out or either in circuit. So here's kind of a fun thing I built. Let's back up a bit. So in the battery compartment are a couple of different fuses. This is called a CNN. It says CNN, but it's also, we call it an ANL. It is a high current fuse. This happens to be a 150 amp fuse. The neat thing about these fuses is that it has a window and you can see, kind of like the ATC fuses, the little blue ones, you can see whether it's blown or not. You see that? This is a mega fuse. This, I believe, is on the generator. So mega fuses are pretty popular. Victron, we use them in solar installations. The problem is you cannot see whether the fuse is open or not. The only way you can do is you have to measure it, with your meter. So if we bring our meter back into the picture and touch our probes as always, make sure it's reading continuity, and I touch either side of the mega fuse, I have an open. If I touch either side of the ANL fuse, it's also open. No, it just I had to get through the corrosion on it. So this is a good fuse where the mega fuse isn't. Here's something cool. Here's what it looks like inside. So a mega fuse is really just a large or mega fuse. You can see that the fusible element in the center here is burnt. So this fuse is open. And the only way you would have known that is either A, check it via voltage, or B, remove the fuse and or power and check it for continuity. So mega fuses, have no visual way of asserting whether it's, open or shorted. Okay. Let's, it'll be fun. Let's play with circuit breakers. So, circuit breakers are under the passenger pedestal. You, as an owner, just see this. This happens to be a 15 amp, and it is a non-tripped circuit breaker. How do I know it's not tripped? Because it's not protruding out. We've had folks who say, I push it in and it doesn't do anything. It does actually go in ever so slightly, as you can see, but it's not doing anything. The circuit breaker is still connected, or it's still good. And we can confirm, again, by bringing our meter into play. Again, checking continuity and putting the probes on the circuit breaker, and we see that it is indeed shorted. So this is a good working circuit breaker. And here's something cool that you don't see often. this is what it looks like inside. So a circuit breaker has what's called a bimetallic element in it. This piece of metal between the two contacts is what's called bimetallic. And what it does is, as it heats up, it changes shape. So when current flows through this circuit breaker and it exceeds the value, in this case it was a 15 amp, I'm going to manually trip it by pulling up on the contact. Look at this section. You see how much farther it's sticking out? So this is now a tripped circuit breaker. We're going to take our probes. Again, short them, make sure we're in continuity. And we're going to put them on these screws. And it is open, because the circuit breaker is tripped. To reset it, you just push this in, click, and you see this device here, which is kind of a guard. It is what obstructs the contacts on a circuit breaker. Here's what we're going to take my heat gun, and I'm going to show you what happens with the bimetallic when it heats up. So I'm heating the bimetallic element up with my heat gun. And someday this week, here we go. So you can see that it's heat related. In other words, when I heated up the circuit breaker, the bimetallic element, it bent up and allowed the spring to push the plunger out, and now we have an open circuit breaker. So the thing to come away from here is that you don't know if your circuit breakers are blown or open not, but you will now, because they need to be sticking out quite a bit, not like that. So there's the difference between an open and closed circuit breaker. Cool. While we're on circuit breakers, here's an AC circuit breaker. This is, on the WIFCO panel, this runs down the left side, and it has functions of, the air conditioner, microwave, and so on and so forth. So it has 3 positions, but normally you only see 2. So this is on. The circuit breaker is in its on position. In other words, the lever here is in the on position. If I move it to the off position, you hear a big click, and now it's in its off position. See that? Turn it back on, and now I'm going to trip the circuit breaker. You can test circuit breakers. Just before as an electrician, before we ever put them into a panel, we always check them. You just have it open and then whack it on the back of your hand. So what I just did is I tripped the breaker. Do you see the position it's in? It's now 90 degrees. So that's a tripped circuit breaker. I have had people try to reset it by just pushing it on. You cannot reset a circuit breaker from a tripped by just pushing it on. You have to push it off and then on. You hear the click? Let me trip it again. See, it doesn't reset. So if you see a circuit, if you blow a breaker in your WIFCO panel, don't expect it to just push it on. You need to shut it off, turn it on. Okay. All right, let's have some fun with this. So I built this little circuit to emulate the WIFCO panel. It has, just so you have an idea what we're looking at here, is a fuse holder, two LEDs. There's an LED. There's a fuse holder here. There's an LED and an LED, a relay, micro switches, a couple of resistors. We're going to power this up, and I'm going to show you how to measure fuses with voltage. We're going to take our little battery. Shut that off. Let's put a good fuse in it first. Where's my good fuse? There we are. Okay. So this is doing what I expected it to do. The circuit is designed that when it sees voltage, it'll have a flashing blue light because we have a good fuse. We're going to set our meter to voltage DC, so volt DC. We're going to measure the voltage going in. I got the black probe on the negative and the plus probe on the positive. And we have 13.58 volts. If I keep the meter negative on the negative battery and I put the probe on the fuse, I get the same voltage, 13.58. If I put the meter probe on the other side of the fuse, I get the same voltage. And the reason is that the fuse is passing the voltage from one side to the next. So this is a good fuse. And we just proved that because we can see the same voltage on either side of a fuse without using continuity. Now, we're going to take that fuse out, simulate that it is a blown fuse. We're going to stick our blown fuse in. Measure our voltage again. Yep, up 13.58. Put the probe on the fuse. We got 13.58, but this time we get nothing. So the fuse isn't passing the voltage from one to the other. So using the meter for voltage, I can actually check the fuse to see if it is indeed good. Now, here's a tricky one. You'll see now I have a red LED with a fuse that's blown. This is simulating the WIFCO panel, that if you had a blown fuse, you get a red LED to tell you that the fuse is bad. Look at the voltages. This is going to be interesting. We got 13.58. We got our 13.58, which is the voltage going in. But now I have 3 volts. 3 volts. The 3 volts is actually what the circuit is using to run the LED, to turn the LED on. In other words, the power to run that LED, it needs 3 volts. That if I shut off the LED, I have 0 volts. So now I'm going to show you why you do not use continuity to check a fuse in a live circuit. If the circuit was completely de-energized, in other words, you shut your main battery switch off and you have no power to the battery, then by all means you can check continuity because there's no power in the circuit. But in our case, we do have power. And we know that because we've got our LED that's on telling us that we have a blown fuse. But watch what happens if I, now continuity, we're going to touch the probes together. It shows it's a short. You might be able to hear it beeping. Watch this. It shows a short. So in other words, if you were to measure this fuse with continuity, you would go, oh, I got a good fuse. I got continuity. So why is this happening? And even if the LED is off, we still get continuity in an energized circuit. And the reason is that in continuity mode on a digital voltmeter, it actually sends a small voltage out these two probes. So if I were to put another meter onto those probes, I would read 3 volts. So the meter's not expecting to see voltage when you're in continuity mode. So if the circuit is energized, it will show a short even though the fuse is open. Good tip? All right. So we discussed that, and we're getting to the end. Time for the ZAMP. So the ZAMP solar, shut off the tail cam. Here we go. So the ZAMP solar connection on the side of our Vita Portos enables you to hook up an external solar panel. You can see that connector. You can see my 2 probes are inserted into the connector with the red on top and the black on the bottom. And this is the voltage that I'm getting. So understand this voltage you're about to see on the meter, 11.14 volts, is actually from my solar panels, and my RV is covered. So it is still putting out a little bit of voltage, but that's why it's such an odd voltage. It's just they're undercover. But this is the important part. You see that the red probe is on top, black probe's on the bottom, and I'm getting a positive voltage. How do I know that? Is because, again, we don't see that little negative symbol under the DC, which tells me that that pin on top is the positive and the one on the bottom is the negative. So that's helpful to know that when you hook up an external solar panel, before you plug it into that ZAMP, you want to make sure that the voltage is correct. And if it isn't, you get, what we call a gender changer or a turnaround, and all it does is it just reverses the male-female so that you will get the correct voltage. Now, if you don't do it, and what you'll do is there's a fuse inside right behind that, of course, Winnebago hid on us, that you need to change out in order to get that to work. So that's just about it. But we have a couple of recommendations. So you remember I mentioned there's something we can use, a device that will let us check our coach battery and chassis battery, and that's called a shunt. Highly recommend it if you're going to make any investment. The next little thing, it is little, it's fairly small, and they're certainly easy to interface, is called a smart shunt. There's a couple of different versions. One is Bluetooth, that you can see the chassis battery and your coach batteries on your phone. And then there's a BMV, which is actually a small meter that is connected to the shunt that gives you an always on view of what the batteries are doing. Highly recommended. They're less than $100 depending on where you find them. It's not only that, but the shunt is kind of your gas gauge. Not kind of, it is. It's a gas gauge for your coach battery. It measures all the voltage and current, or should I say current going into the battery and current going out. Just like a gas gauge or the fuel gauge on your Sprinter. If it's set up correctly and calibrated, it is a very handy device to have. Not that it negates the meter, this whole hour and change of presentation it's not going to negate that, because still you need to test fuses. There's a bunch of things obviously we went over that having a DVM is extremely handy. Will save you hundreds of dollars from calling an RV tech to find something that's either disconnected, a loose connection, or a fuse is blown or a breaker tripped. So the Smart Shunt is just an addition, but it is a very, very valuable device to have. That's kind of all I have. I'm hoping unfortunately, I don't see who's connected or who's talking or what. This is because of the latency. I don't get to see anything. But I hope you enjoyed it. I will put up links probably tomorrow for what a Smart Shunt, what meter. I believe I already have the meter that we were playing with. And if there's any questions, please by all means reach out. I love answering questions and anything I can do. So I hope you all learned something. I hope you had fun. I hope I didn't bore you to death. And I look forward to seeing you guys on the road at some point. All the best. God bless. Travel safe. Talk soon. Bye-bye.